All right, so I'm just going to quickly run through how to answer these questions. So here we go. We're just going to get rolling. So number one says, what is the solution to this equation? So of course, solution means to solve for x, right? So we're trying to get x by itself. You can work this one a couple of different ways. You can either subtract the 6 on both sides first, or if you want to get rid of that fraction, right? The fraction is dividing by 3. So if you want to get rid of that first, then you can totally do that. I'm going to do that. So I'm going to multiply. Remember, to get rid of a 3 divisor, we are going to multiply every single term by 3. Right? And so obviously 3 times a third is just 1x, which I'm just going to write as x because the 3's cancel. 6 times 3 is 18, and 9 times 3 is 27. And that looks much nicer, right? Much easier to work with without the fraction. So I notice the only thing I really need to do is subtract the 18 from both sides to get rid of the positive 18, and that is what's going to give us x equals 9. You can always plug your answers back in and check, right? And you'll notice if I plug 9 in for x, I'm going to end up getting 9 equals 9, which is true. All right, the next one, we're also solving the equation for x. This one has a little bit more going on because you have parentheses, right? So we want to make sure that we are distributing and multiplying that number through. So 3 times x is 3x, and 3 times negative 5 is negative 15. Now on the other side, I'm just going to bring that 5x down because he has nothing to do with the parenthesis because there's actually an understood negative 1 multiplier sitting in front of that parenthesis. So negative 1 is what I want to distribute. So negative 1 times 3 is negative 3, but negative 1 times negative x is positive 1x. All right, so I'm gonna kind of write my steps over here as I go. Right, so step number 1, distribute. All right, now you'll notice here's my equal sign, right? But something else I notice is that over here on, I don't want to do that, let me highlight. Over here on this side, I have 2 x terms, right? And we always want to make sure that all of our like terms are combined. So on the left side, I have an x term and a constant. So I can't do anything with 3x minus 15. But 5x's plus 1 more x gives me 6x's total on that side, right? So that's my second step, right? Combine like terms, if you have any, on one side of the equal sign. Remember, if they're not on the same side, then they're not like terms yet, right? So now, excuse me, now I notice I have x's on both sides. Well, now I have to do some algebra, right? Because now I have to get all of my x's to one side, right? So I'm going to subtract my 6x's. I'm just going to get all my x's to the left. You can get yours to the right. It really doesn't matter. But those are positive 6x's over there, so I need to subtract them if I want to move them to the other side. Now I can combine the like terms because they're on the same side. And 3x's minus 6x's is negative 3x's. And that, don't forget, that's a negative 3, right? That negative belongs to that 3. So I'm going to kind of put my next step here. X terms to one side, right? Now I've got all my x's to the left, but I have constants. I've got a constant on the left and a constant on the right, and I need them all on the right, or whatever the opposite side is from my x's. So we are going to add the 15s over here. All right, and so that is going to give us negative 3x equals positive 12. All right, and so next step, constants to other side. And then once we have that situation, our last step should be to divide by whatever that coefficient or multiplier is in front of the x. Right, and so we're going to end up getting x equals negative 4. Kind of ran out of room there. Right, so our last step was to divide. Right. So quite a few steps on that problem, right? But just kind of taking it one step at a time. You don't need to rush. Just algebra is all about going slow and rewriting every single step out so you don't lose track of where you are. All right, on this next guy, solving the inequality. Okay, so very much the same thing. I don't have any, I'm going to kind of run through the exact same steps that we just did a second ago. I don't have to distribute though, because I don't have any parentheses. I don't have any like terms to combine because on this side there's x's and constants, and on this side there's x's and constants. So there's no combining of like terms because there's no like terms on the left or the right. But so now we're on this step, right? We got to get all of our x's to one side. Now when I do inequalities, I like my x to be on the left to make sure that I read it correctly, right? So I'm going to subtract my 8x to the left side. Now I have like terms that I can combine. So negative 11x minus 4 greater than 7. All right, now I'm on this step right here. Get all your constants to the other side. Well, if I took all my x's to the left, then I need to move my constant to the right. All right, so I'm going to add the 4. And that's going to give me the negative 11x. I'm going to bring that down, is greater than 11. And then my last step is to divide. So I'm going to divide by negative 11 on both sides. Little bells should be going off in your head because you're solving an inequality and you just divided by a negative, which means we just changed the truth value of this entire problem. So we need to switch the inequality to keep it true. And of course, 11 divided by negative 11 is negative 1. And so this is our final answer. And I know it didn't ask us to, but I'm going to go ahead and graph it just as a little refresher of what that means to graph in one variable, because we've been graphing in two variables lately. So here's negative 1. And remember, that would be an open circle because I can't actually equal negative 1. Right, and then I want all the values less than that. Well, all my values less than negative 1 are to the left. All right, so that's what my graph would look like on that one. All right, moving along. The sides of a rectangle have a length of x plus 4 and a width of 2x plus 5. If you need to, don't ever hesitate to draw a picture when you have a rectangle problem. All right, so the lengths are x plus 4. Remember, there's two lengths. And the widths are 2x plus 5, and there's two of those as well. All right, so this is kind of what our picture looks like. It says, write an expression, right? Remember, an expression doesn't have an equal sign, that represents the perimeter of the rectangle, right? And remember, perimeter means to add the sides. Add all the sides. And you can also, to make lighter work of that, remember our perimeter formula. We've been using it kind of recently with our systems, right? Perimeter is 2L plus 2W, because obviously if I go around the rectangle, right, we hit two lengths and two widths as we travel around, right? And so in order to write his expression, I know it's going to be two lengths, which are x plus 4s, plus there's two widths, which are 2x plus 5. So that's technically my expression, except we want you to clean that up a little bit because we don't want any parentheses and we don't want like terms. So we're going to clean that up by distributing. If you don't want to write it this way, you can literally just say this plus this plus this plus this and add all four pieces together. You don't have to use the 2L plus 2W formula if you don't want to. All right, so that's going to give us 2x plus 8, and then, 4x plus 10. And then, of course, we have some like terms, right? We've got x terms. Let me get the signs in there. So we've got positive 2x's and positive 4x's, which gives us a total of 6x's, right? And then we have positive 8 and positive 10, which when we combine those constants, we get positive 18. Right, and that is going to be our answer. Let me bring that down just a little bit. There we go. So that is the expression for the perimeter. Okay. Number 5, simplify the expression. Again, notice there's no equal signs, so we're not solving anything here, right? We are multiplying all of this out. So we are multiplying a binomial times a trinomial. So we'll be doing a lot more of this in the next few weeks, but we did this in Unit 1. You need to do this one of two ways, right? Most of you guys kind of found your niche and decided how you wanted to do this in Unit 1. So you either need to double distribute, meaning the x has to get multiplied times every term over here, and then the positive 4 has to get multiplied to every term, right? Every term in the binomial has to get multiplied by every term in the trinomial, right? So if you want to double distribute, right, you can get it that way. Your other option, if you remember, is you can use the box method, right? And if I'm multiplying a 2 term by 3 term, I would create a 2 by 3 box, right? And then I could put the x plus 4 along the top, just because I made it this direction. And then 2x squared minus 3x plus 5 along the side. And then you're just kind of multiplying, right, like a Punnett square. So 2x times 2x, x times 2x squared, right? Remembering your multiplication rules, right? So that would give me 2x cubed, because you add the powers, remember? When you multiply, you add the exponents, right? And then to get this box, we multiply positive 4 times 2x squared, which gives us positive, I always like to put the sign in the box with the term, positive 8x squared. Then we want to multiply x times negative 3x to get that box. Well, keep in mind, this is an understood 1 also, so when I multiply, I add the exponents, and I'm going to get negative 3x squared. My square disappeared. There we go. And then to get this box, right, we're going to multiply 4 times negative 3x, which is going to give us negative 12x. And then to get the bottom left box, we multiply x times positive 5, which gives me positive 5x. And then the last box is positive 4 times positive 5, which gives us positive 20. And of course, if you choose to just distribute, well, then you're going to get these exact same 6 terms. You're just going to have it written out kind of horizontally as opposed to it being organized in a box, right? It's the exact same thing. Now, you're not done, of course, because you need to clean all this up and combine like terms. And remember, if you've done this correctly, all your like terms should lie on the diagonals. So I noticed there's only one 2x cubed term because he's a corner box. So he is his own diagonal. Then we have this diagonal, which is all of our x squareds that we're going to combine. Then we have this diagonal, which is our x terms. Right? And then we have the constant, and he's the only one because, again, he's a corner box. So I really like the box method because it double checks to make sure that you got your x cubes and x squares and x's and everything all correct, and you didn't accidentally miss an exponent anywhere. All right, with that being said, I'm going to write down my answer. So 2x cubed, I'm going to try to color code it here. And then if I combine my purples, negative 3x squareds and 8x squareds gives me positive 5x squareds when I combine like terms. And then my blue guys, 5x's and negative 12x's makes negative 7x's. And then, of course, our plus 20. And that is our final answer. All right, moving on to number 6, simplify this expression. All right, well, this is a little quicker because this is just a monomial, right? They didn't put him in parentheses because he's only one term, but if you want to think about it as basically the same as the previous problem, you can. But it's a monomial times a trinomial, right? So this 2x, he needs to get multiplied by all 3 terms. Remember, you can multiply anything in math. anything can get multiplied together, but you can only combine like terms. I can only add and subtract like terms, right? X's can only be combined with other X's, but I can multiply X squared times X cubed or whatever all day long. I do want to remind you of your exponent rules. I'm just going to throw a little example over here. Remember, X squared times X cubed, for example. I'm just going to move this up here. Right, remember you add the exponents. When you multiply x's or y's or whatever, right, you keep the base and you add the powers. Right, so this is just a little reminder. I'm just going to put remember. These rules are actually on your formula chart that we've been using recently. All right, so here we go. If I multiply, I'm going to do these first two terms. 2x times y squared. All right, well, I'm just going to write that as 2xy squared. Remember, you can multiply anything. You just shove it all together. All right, and now I'm going to multiply 2x times 3xy. All right, so remember, now I have x's. I have an x to the first and an x to the first. So when I multiply this term times this term, obviously 2 times positive 3 is positive 6. And then x times x gives me x squared because I add the exponents, and then the y just gets attached. All right, and then of course lastly I'm going to multiply the 2x times the positive 3, which is just positive 6x. And that's my final answer because I don't have any like terms to combine, right? This guy right here, he's an this guy is an xy squared term. He can only be added to other xy squared terms, and I don't see any more of those, and the same goes for the rest of them. Okay? All right, moving on to number 7. It says solve for y. All right, well, I noticed that I have x's too, so this is a literal equation. Let me just write that over here. Literal equation, right? This is when you have an equation with more than one variable, and you're asked to solve for one of the variables. Just like y equals mx plus b. Just think of this as y equals mx plus b, right? We're trying to get the y by itself, right? It's no different. All right. Now, again, if you're trying to solve for y, if you would rather your y be on this side, then just switch the equation. We talked about this in class the other day. I'm just going to move the 4y plus 5 to the left side, and then move the 3x minus 2 to the left. I haven't changed anything. I'm just swapping sides of the equal sign. So nothing changed. I just swapped the left and right sides. All right, and again, you don't have to do that, right? It's just if you're more comfortable with the y being on the left, like we're used to with y equals mx plus b. So I happen to notice that I need to start getting this y by itself, and we always move the number that's not attached to the variable first. So we need to get rid of this plus 5. So we're going to subtract 5, and I can only subtract constants from other constants, right? So that's going to give me 4y equals 3x, and then of course negative 2 minus 5 is going to give me negative 7. And then I need to get rid of that 4 multiplier on the y, so I'm going to divide every single term, because whatever you do to one term, multiplying or dividing wise, you have to do it to everybody. So the 4's cancel, and I'm left with y equals, and I can't really do anything with the 3/4, so that's what I'm going to write down, 3/4 x, and then minus, and I can't really do anything with 7/4 either. Now, if you want to write it as 1.75, if you type it in your calculator, you're more than welcome to, but no need, right? Why waste the time? You can just leave it as a fraction if you want. And it's okay to have fractions, no big deal. All right, number 8 is kind of going back to, let me just zoom back up here, our little remember this rule, right? That when you multiply, you add the exponents. That's the exact same thing that's going on here, right? There are no plus or minus signs anywhere in this problem. This is a monomial, that is all one term, and we are literally multiplying it times this monomial, right? So 3 times 8 is 24. X cubed times x to the 4th, right? We're going to add the exponents. You keep the base and you add, because there's 7 total x's in the problem. If you were to write this out longhand, which I'm not going to do here, And then I have 2 y's, and I'm adding 6 more y's to the chain of multiplication. So that's going to give me 8 total y's. Right? And that is my answer. If that trips you up a little bit, let me scooch this down. If you want to, remember, you can think of this as 3 times x cubed times y squared times 8 times x to the 4th times y to the 6th. Right? If you want to get rid of the parentheses and just write everything out as its own personal factor, right? And then you can just kind of multiply all the numbers and then all the x's and then all the y's together, right? You can think about it that way as well. All right, over here, now this is where we need to remember what happens when we have a power on the outside of other powers, right? Because we've got powers inside the parenthesis and we've got powers outside the parenthesis. So this is a power to a power. So I'm going to do another little remember box over here. So let's see. There we go. All right, so remember, when you have a power raised to another power, so let's say x squared to the 4th, that's when you multiply the powers, right? Power to a power, you multiply the powers. So that would be x to the 8th, right? So when you're combining x's, you add. When you're multiplying powers to powers, you multiply. Those are really the only 2 rules you need to remember, okay? Now the reason why this 2 is on the outside of that parenthesis is because everybody has to get the square. If it helps, I'm going to write this out in expanded form, okay? So this is going to be -3, and he gets the square. Then x to the 5th, he gets the square. And then the y cubed, he gets the square. So I'm kind of doing what I did over here, right? And I'm expanding each factor, right? Then we have, over here, we've got the 2, and he has to get cubed, right? Because every factor has to get the power, right? I have 3 separate factors going on here. So the 2 gets the cube, the x cubed gets the cube, and the, oops, I forgot my parentheses. And I'm totally running out of room. It takes a lot more space to expand. And then y to the 4th cubed. And the reason why I wrote it out like this is because, right, I want us to, oops, I'm so sorry. I want us to see that rule, right, where we have that power to a power, okay? Now, the cool thing about this guy and this guy is these are just numbers, and you can just legit type that into your calculator, right? So I know that -3 squared is +9. Please, if you're going to type that in your calculator, you must put the -3 in parentheses. It's not the same thing if you don't. Then here I have x to the, let me get a different color. I have x to the 5th squared. That's a power to a power. So I multiply the powers. So that's going to give me x to the 10th. Then I have y cubed squared. So that's a power to a power. So y to the 6th. Okay, then I have 2 cubed, which means 2 times 2 times 2, which is 8. That's a weird looking 8. There we go. And then we have x cubed, right? So power to a power, right? And so that's going to give us x to the 9th. And then we have y to the 4th cubed. So power to a power, that's going to give us y to the 12th. All right, and we're still not done, right? Because we have stuff that we can multiply together. We have all these like bases. So we have constants or coefficients, I guess, 9 times 8. So we can actually do that math. So 9 times 8 is 72. And then we want to add the x to the 10th times the x to the 9th, right? And so remember, that's when we have like bases. So we add the powers, right? When you multiply, you add the exponents because we want to merge all the x bases together. And then the same thing with our y's. We've got 6 y's and 12 more y's, which is a total of 18 y's. And that is our final answer. All right, so we're using the power to a power rule and the multiplying like bases rule. All right, moving on. Number 10. This exact question was on one of our tests, so it should sound familiar. Eric earns $7.50 per hour. All right, as soon as I read that, or as soon as you read that, I'm really hoping you are thinking soap, right? Because anytime you see a rate like that, the total amount of money he earns on a given day is a function of how many hours he works. If he typically works between 1 and 5 hours a day, what is a reasonable range for this function? Okay, so a couple things you can do here. I'm a sucker for a table, right? Anytime I can, I like to kind of make a table, just because it's really easy to fill in for one, right? And so I know my X and Y. X is number of hours, and I know that because of the per hour, right? And I know Y, and Y is the total money that he earns, right? Now, here's the thing. We know right here it says he works between 1 and 5 hours. And the reason why that's so important is because we have 1, 2, 3, 4, 5. I know exactly what my X values should be because it says he works between 1 and 5 hours. So he doesn't work less than an hour. He doesn't work more than 5, right? And they're telling us that in the problem. Well, if he works if he earns $7.50 per hour, well, that's pretty easy to fill in this table, right? If he works 1 hour, well, then clearly he makes $7.50, right? If he works 2 hours, then he makes double that, which is $15. Right? If he works 3 hours, we add another $7.50, right? So he's going to make $22.50. If we add another $7.50, he's going to make an even $30. And if we add another $7.50, that's going to be $37.50. Right? So remember, the reason why we want to do this is because we can find domain and range. Now, remember, there's 2 different types of domain and range. I know I didn't ask for domain because it actually gave it to us, but just bear with me. So remember, there's 2 types of domain and range, right? Or 2 types of data, I should say, right? There's continuous data, and there's, I'm going to put or, there's discrete data, right? And you have to remember that anytime you have continuous data, that means your domain and range are going to be written as inequalities. Okay? And when it's discrete, you're just literally listing the X and Y values because they're just dots. Now remember, in order to figure out what type it is, you always go look at the X variable. Well, our X variable is time. And time is always continuous, right? So time is continuous because basically, remember, continuous means fractional. So could he go to his job and work 3.5 hours? Yes. Could he work 4 hours and 10 minutes? Yes. So we don't want to just include the hours. We want to include all the minutes that are between them too, right? So we need our domain and range to be continuous, which means our answer is going to have to be written as an inequality, right? We're not just going to list these money values, right? Because he could earn the decimal money values in between by working the decimal hours in between. All right, so here we go. So our domain would be written as 1 is less than or equal to X is less than or equal to 5, right? Because we're talking about hours. And then the range, right? We filled in this lovely table. $7.50 is the bare minimum amount of money he could earn. Equal to. And the maximum, if he works a maximum of 5 hours, then he can only earn a maximum of $37.50. Right? Now it technically only asked us for the range, right? And so that would be our answer. You could also, if you want, you could use the 750 per hour to write the function, which would be y equals 750x, right? And you can plug in the 1, 2, 3, 4, 5 into the function, and you would get the exact same values. Okay. All right, let's do a few more. Number 11, identify the y-intercept of the graph. All right. Well, the y-intercept is where it crosses the y-axis, and it appears as if this guy only crosses the y-axis right here, right? So our y-intercept, I'm just going to write it like this, would be the point 0, 4. And please remember to always write your y-intercept as a point, right? And don't just write 4, okay? All right, next up, we'll talk more about attributes of graphs here. Number 12, this is the graph of a quadratic, 6x squared minus 11x plus 3. You don't have to worry too much about that yet. But it says, what are the zeros of the function? So remember, zeros is just a fancy name for the x-intercepts. And you need to know that. It's very important. There's lots of different names for x-intercepts, right? So we have zeros, solutions, and roots, right? All 3 of these, or all 4 of these words, right, including zeros, they all mean the exact same thing, right? And all they're doing is asking you to find the x-intercepts, right? So we're trying to find this and this. Now, this is a pretty crappy question because obviously those are not going through perfect values for you to figure out what that is. I really don't want you eyeballing it, but I do want you to notice that there are 2 of them, right? So I'm going to make sure that's the main thing I want you to know. I'm going to put blank and blank. Now, I'd like to get as close as possible to what those true values are because clearly I don't know what those decimal values are. Let's go use Desmos. Why not? You're given the function 6x squared minus 11x plus 3. Let's go throw that in there. Desmos. Here we go. It's thinking about opening. There we go. So I'm just going to type it in. Y equals 6x squared minus 11x plus 3. And there's that exact same picture. And you know the really cool thing is when I zoom in, if I just tap on the y-intercept, the x-intercept, I mean. Why is it doing that? There we go. Right, when I tap on that, it's telling me 0.333. And I'll just let you write that, which is probably a third because the decimal actually goes on forever. But that's okay. Right? So I'm going to put in 0.333, comma 0. So that would be our first guy. And then I'm going to go back to Desmos. And I'm just going to tap on this gray dot. And it says, 1.5. Exactly. So 1.5, comma 0. Right? So Desmos to the rescue. So we don't have to eyeball it and try to just guesstimate. That's going to be 1/3. So if you want to write 1/3, you certainly can. But 0.333 is fine. All right, number 13, the function y equals 2 to the x. So remember, this is the parent exponential function. If you've already done the last page of this review, it reviews all of these. Parent exponential function. Identify the x and the y-intercept. All right, well, the y-intercept is 0, 1. Right, because anything to the 0 power is 1, right? You're literally plugging a 0 in for the x, and 2 to the 0 power is 1. And then the x-intercept is where it crosses the x-axis. But remember, the parent exponential function, he never gets to the x-axis, right? Because he's half, and then he takes another half, and then half, 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 half. And in theory, he's never, ever going to get there, right? So he does not have one. So you're just going to write none, okay? All right, number 14, determine if the ordered pair sets below represent a function. All right, so remember functions, just really quick, the x's cannot repeat, right? Or else it fails the vertical line test, right? That's how we know if it's a function or not, right? X's cannot repeat for it to be a function. Okay, so basically that's what I'm going to do on these points. I'm going to go look at all my x's, 2, 4, 6, 8, 10. Oh, my x's did not repeat. So yes, function. Okay, if I go over here to this guy, right, look at my x's. I don't care about the y's. The y's can repeat all day long. It's just the x's that can't. 0, 2, 3, 2, right? 2 shows up twice. That's bad news. Right? So repeating 2's, right? So no, not a function. Okay, so they're repeating 2's. Make that a big no. All right, number 15, given f of x being this lovely quadratic function here, what is the value of the function when evaluated at f of -3? Now, we've talked about this so many times. Please remember when you see this is just called function notation. This just means to go to the f function and plug a -3 in for x, right? They are legitimately just telling you in this problem that x equals -3. That's all that means. So basically, I'm going to come over here and I'm just going to rewrite f of x, but everywhere I see an x, I'm going to substitute a -3 in parentheses. All right, I'm just going to put a -3 in everywhere I see an x. So there's an x there and there's an x there. And then all you have to do is just type all of this mess into your calculator, right? Or you can do it in your head one step at a time or whatever floats your boat, right? And that is when I type all of that in. All right, I'm going to get 18 minus 15 minus 9. So that is going to give me -6 when I type all that in. And that's my answer. And I'm just going to write f of -3, which just means go to the f function and plug a -3 in, and then tell what we get for the output, which is -6. Which, remember, is just a fancy way of telling us that the point -3, -6 lies on the graph. All right, that's really what that's saying. Now, just for giggles, how about we go to Desmos and test this little theory? I'm just going to go in and type in that function, y equals, or you can type in f of x. Here, we'll go ahead and do f of x. Why not? F of x, which is the same thing as y. And I'm just going to type in the function. I'm not going to plug the -3 in. I'm just going to type in the function he gave me. And then I'm going to go type in the point that I got. When I put in a -3, comma, I should be getting out a -6. Now let's go look at our graph. Oh my goodness, what do you know? Right here. I can't really use my pen on here, right? But you see my little green dot, right? He's perfectly on my function, right? Which proves that I did all my math correctly, right? The point -3, -6 does lie on my quadratic graph. Okay, this is wonderful Desmos, right? To check all my answers. All right, let's just do a few more here, and then I'm going to cut this video off, and I'll go to the next section. All right, so on number 16, it says a sequence. So sequences. So remember, there's two types of sequences. I'm just going to do a quick little review here, right? There's arithmetic sequences, where you add where you add or subtract to get the next number in line, right? And then we have geometric sequences where you multiply to get the next number in line. Okay. All right, so here we go. A sequence can be generated by using the rule A sub n. That should be a sub n, by the way. I'm going to actually write that the way it's supposed to be written. It should look like this. A sub n equals 4a sub n minus 1. That is what that's supposed to look like. It's just typed like that because the person typing it didn't know how to do subscripts, right? And then right here it's saying A1 equals 6, which is basically saying A1 equals 6. Oops, I forgot the equal sign. All right, so you need to know how to interpret this, right? So remember, A sub 1 means your first term in the sequence. Remember, a sequence is just a list of numbers, right? So if I go over here, 1, I'm just going to start writing some little blanks. There we go. All right, so essentially, let me make that one really short. Okay, so essentially it's saying the first term is 6. All right, so I'm literally just going to say A sub 1, and I'm going to move that over here. All right, now what this is telling me, sorry, let me go over here. What this is telling me is that to get to the next term, or any term, I take the term before it and I multiply by 4. So that means this is a geometric sequence, right? Where it's just a 4 multipliers. So literally all you have to do is come over here. If you know you're starting at 6, you're just going to multiply by 4 to get the next number in line, which is 24. Then I'm going to take that new number and I'm going to multiply by 4 to get the next number in line, which is 96. Then I'm going to take 96. I'm going to multiply him by 4 to get the next number in line, which is 384. Okay, I don't know why I put a fifth blank because it clearly says what are the first 4 terms in the sequence. So this is my answer. The first 4 terms in the sequence is 6, 24, 96, 384. Okay. All right, number 17, the graph of some linear function, they're just calling it k, no big deal, passes through the points negative 7, 0, and 1, 8. What is the slope of the linear function? Okay, so remember slope, nice easy formula. It's on your formula chart if you ever forget it. y2 minus y1 divided by x2 minus x1. Okay, so again, it doesn't really matter which point you start with as long as you start with the same point both times. So if I subtract 8 minus 0, I have to go back to that second point and make sure I'm subtracting in the same direction. So 1 minus negative 7, which remember that gives me a double negative. And so that's going to give me 8 over 8. And of course, 8 divided by 8 is 1. Okay. Now, I'm going to sketch this just really quick. You don't have to do that. It doesn't really ask you to, but I just want to make sure everyone's understanding what's happening here. So the 2 points they gave us were negative 7, 0. Let's say negative 7's there. And then 1, 8, which is like here, right? So this is our line. And we just found out that he has a slope of 1, positive 1, which makes sense because it's clearly an increasing line and I should clearly have a positive slope. Okay, now I'm graphing it because of this next question. It says, what is the 0 of this linear function? Or remember what 0 means. 0 is a fancy term for x-intercept. So I'm going to go back to my graph. Do we know what point this crosses the x-axis? Yes, we do. They actually gave that to us, right? We don't have to go hunting for it or anything. It's literally right there in the problem, right? They told us right here that it's passing through negative 7, 0. That's the x-intercept. So just kind of having the awareness, right, of the fact that that point was actually provided to you. All right, number 18. Y equals 3.75 plus 1.5 times x minus 1. That's a lot going on. Can be used to determine the cost in dollars for a taxi ride of X miles. Okay. What is the rate of change of the cost in dollars with respect to number of miles? Okay. So again, you don't have to write this down. I just like to kind of make sure I understand what's going on. So if I was to make an XY table, right, this would be number of miles would be my X values, right? And then total cost, right, would be my Y, right? So if I were making an XY table, that's kind of what that would look like. Now it does ask me to find the rate of change. Now, if you don't know what that means, then you're going to have a problem, right? So remember, rate of change is just a fancy word for slope. Well, how do I find the slope of linear equations? Well, I don't know about you, but I find it super helpful if my equation is in y equals mx plus b form, because the m is the slope, but it has to be in mx plus b form. I just can't go picking any number that's sitting in front of an x and call it the slope, right? It has to be in y equals mx plus b form. Okay, so I'm going to take this equation. I'm going to rewrite it down here so I get a nice, I can start working with it. Oops, forgot my parentheses. There we go. I am going to, it's already got y equals, so I'm super thrilled about that, right? The y is already by itself, which means I just need to clean up this mess, which means distribute and combine like terms so that it looks like mx plus b form. So I'm going to distribute first. So I'm going to bring down the y equals 3.75. All right, 1.5 times x is 1.5x, and 1.5 times negative 1 is negative 1.5. And then I have some like terms to combine, right? I have a constant here and a constant here. And so that is going to give me y equals, now I'm going to put my 1.5x, I'm going to bring him down first, right? Because I like the mx plus b, so I like that first. And then, of course, 3.75 minus 1.5 is going to give me plus 2.25. All right, so this is my linear equation, right, in y equals mx plus b form. And clearly it appears as if my slope is the 1.5. And if we interpret that meaning, right, that means $1.50 per mile. Right, and so that is our constant rate of change. All right, number 19, we've got a table of values. It does say it's a linear relationship, right, which means this is not going to be a linear regression. Even though if you want to put it into Desmos, you can. It'll tell you what the slope is without you having to do any work. But that means this is going to be a perfect, right, this is going to be a perfect linear relationship. So they're telling you that in the problem, okay? And they just want us to, oopsies, where is that? There we go. It says, based on the table, what is the rate of change? Well, we just talked about this, right? Rate of change is the slope. But they didn't give me an equation to work with. They gave me a table. So remember, you could do one of two things. Number one, go grab 2 points. Any 2 points from the table, it doesn't matter, right? If you want to pick 0, 32 and 1, 39, right? Just go pick any 2 points and then use your slope formula. This is option number 1. Right? That's option number 1. Option number 2 is just literally to just go find the change in y and the change of x in the table, right? So that's what I'm going to do. I can see clearly that my y's changed from the first to the second point. We added 7. And to get from the first x to the second x, we added 1. So those are my changes. So change in y, 7, over change in x, 1, right, which gives me 7. Or 7 over 1, which means $7 per week. Right, if you want to get fancy with it and actually explain your slope. You'll get the exact same answer, right, if you do the formula, right? You can clearly see you're going to get 7 over 1. And if you pick any of these other points, you may not get 7 over 1 directly, but you'll get something that reduces to 7 over 1. So you might get like 14 over 2, right, which when you do the division, you get 7, right? And so you should get there eventually at some point. Okay. All right, I think I'm going to stop there on that video just because it's getting kind of lengthy. And then I will pick up and do the rest of the problems in the next video.